Welcome back, guys. Welcome back to the channel. Today on this video we'll be proving the trigonometric identities. As you can see there is a problem there whereby on the left hand side we have 2 cos sec 2x, which is equaling to tan x plus cot x. So in this expression we need to prove that the left hand side is the same as the right hand side. Now before you prove, guys, one of the things that you must always consider, or before you prove anything, you must always look at which side is complicated. Now between the two, the side on the right seems to be more complicated compared to the side on the left. So I would say choose the right hand side. So you can do this problem, pause the video and see whether you're gonna be able to get the same answer as the one that I'm going to get. Before we start, do not forget, guys, that at the end of each video there is a playlist that shows the sequence of these videos, if it so happen that you want to start from part 1 till the last part. Alright, guys, now let's start. So let's choose the side which is the right hand side in this case. So we can say, we can write right hand side. You can say right hand side, which is the same as tan x plus cot x. Alright, so just like when we are solving or simplifying, guys, try to change the tan and the cot and the sec and the cosec into sine and cos. It's way easier when you do that, guys. Way much easier when you do that. So let's do this. So this is gonna be sine x over cos x. Alright, plus now cot is the opposite, which is gonna be cos x over sine x. Alright, if you don't know where these are coming from, basically these are the quotient identities. So for sine is equal, for cos, tan is equaling to sine over cos, and then cot is equaling to cos over sine. So these are quotient identities, guys, so be very careful. Alright, let's look at the denominator. So we can say cos and then multiply by sine. Remember, there is a positive sign here, meaning we need to find the denominators. These are adding each other. Now let's continue. So the next step is you divide our denominator, which is cos multiplied by sine, by the cos. So if you say cos multiplied by sine multiplied by cos, you'll be left with sine, and that sine multiplied by the sine here on the numerator, which is going to give us sine squared, and then we have plus, and then we do the same thing here. We say the denominator, which is cos multiplied by sine, divided by sine, you're going to be left with only cos. So this cos that you're left with, you're going to multiply by the cos as our numerator there. So you're going to have cos squared x. Right, so this is what we have. Now we have to continue. When you look at this numerator here, we have sine squared plus cos squared. This is an identity which is gonna be 1. There is an identity, guys, the square identity. I'm gonna write it here: sine squared plus cos squared x is equaling to 1. So we can change that here, and then from here we'll be left with cos x. Now cos x multiply, not plus, almost wrote plus there, multiply by sine x. Now when you look at this problem, you can be you have to be careful. Look at our denominator here. We have cos multiplied by sine. We have an identity similar to this. So I would say to you, first rewrite this in this form because it's going to be very useful. Now if you rewrite this in this form, we have cos x, and just put them in a bracket, multiplied by sine x. Right, so this it's an identity, guys. There's an identity like this one where cos and sine they multiply each other, and it's a double identity. All right, let's look at these double identities. All right, you know that this is gonna be 2 cos x multiplied by sine x. Guys, if you don't know about this identity, I left the icon on top there. Go and watch that video where I derive this identity, how this came about, guys. Right? Okay, let's continue. So if you want to make cos x multiplied by sine to be Surrey formula, you have to divide by 2 both sides. So if you divide by 2 this side, obviously this is gonna be half sine 2x, and that is gonna be equaling to cos x multiplied by sine. Right, as you can see, this is the same as what we have here on our problem. So meaning we can say half sine 2x when we come to this one. We can substitute that one. So we can say 1, alright, divide by, now we have half sine 2x. Right, so we can substitute by that one. Now with what we have, now let's continue, and now we can say 1. Now we can change the denominator here. Let me just divide by 1 here, because some people might not even able to see. We can change here and do the multiplication. So when we change the multiplication, the denominators they become numerators, and the numerators they become denominators. So we can say now 2 goes up here and then multiplied by, and then our 1 here also goes up there, and we have sine 2x go to the numerator. So if you continue, this is gonna give us that. Let's just continue like that. It's gonna give us 2, and then what is our reciprocal of sine? 1 over sine. What is our inverse of 1 over sine? We can change this as well. So our inverse of 1 over sine is gonna be cosec 2x. Guys, if it so happen again you don't understand where this reciprocal come about, there is a video whereby I discuss this reciprocals. Then you multiply here, and then you have 2 cosec 2x. When you look at this side here is the same as the left hand side. Alright, so guys, this is how you do it. If it so happen that you didn't understand, you can continue and watch the video over and over again. But basically, this is how you do it, guys. Don't forget to change the trigonometric ratios to sine and cos. If you have your tan, your cot, your sec, and your cosec. Alright guys, so at the end of this video there is a playlist. If you want to watch from part 1 until this part, which is part number 12, you can click on that playlist, and then you can able to watch the videos in a sequence form. Guys, thank you very much guys for watching. If you find this video useful, do not forget to like, subscribe, and comment. Until next time, cheers.